Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the January 2023 Pure Mathematics P1 International A-Level Edexcel exam. This question is about trig graphs here. It tells you that figure 3 shows a sketch of the curve with y equals tan of x. The straight line 1 or L, with equation y equals pi x. So this is the straight line. The equation of this line is y equals pi times x, and the interval is in the interval from minus pi to pi. So this is from minus pi up to pi. As we know, at pi over 2, which is in degrees 90 degrees, there is an asymptote. So we can see there's going to be an asymptote in these places here. Made them a bit thick anyway. Okay, those are the two asymptotes, which is the places for which this curve has x values which are undefined, this y equals tan of x. All right, now, and that's pi over 2 and minus pi over 2 in this range. So that's pi over 2, and that's minus pi over 2. Okay, now it says, state the period of tan x. Okay, now, the period of a function is, how often it repeats. Okay, so the period of the tan curve, it repeats the same shape like this. Will continue repeating if you carried on drawing it this way and that way. Just continue. This shape here repeats continuously. You can just copy this and keep pasting at the end, and it will be the tan curve on both sides. So between minus pi over 2 and pi over 2, that is pi radians. So the period of this graph is pi radians. So we can just write down the answer as pi. Simple as that. Just state the period. Don't have to show any steps or anything. Just state it. So pi is the answer. The answer to question 9a is pi. Then it says part B, write down the number of roots of the equation tan x equals pi plus 2x in the interval from minus pi to pi. So this is minus pi again, and this is pi. Now, this is where y equals pi plus 2x and y equals tan x. This is where they intersect. The solution to this equation will be where these two intersect. Now, what is y equals pi plus 2 times x? That looks a bit weird. Well, pi is just a number, and 2 is just a number. So this is like, for example, we know that this is y equals pi x, which is like y equals 3.142 times x. That's the equation of that line. The equation of this line is basically y equals 5.142x, because it's just a number, which is 5.142 and so on, because it goes on forever. But it's a line which has a greater or a steeper gradient than this, because this is like the m part, y equals mx. They both go to the origin plus c is 0. So this graph looks the same as this line, except it's steeper. It's a straight line, but it's going to be steeper than that line. So we draw a line going through the origin steeper than that line. That would be y equals pi plus 2 times x. I get this line that I drew. It doesn't want to come. Okay, there it is. So this line is a line that is slightly steeper than the line that we told L was. This is y equals pi plus 2 times x. Right, so that's that line. And it says, write down the number of solutions of this equation where these two intersect, okay, between minus pi and pi. So you can see from this diagram that basically what's going to happen here is that this line will continue going down forever here, and this curve will come down, but after minus pi it won't intersect it again. And on this side, this curve is going to go up again. They're going to intersect somewhere again, but between minus pi and pi, there's only these 3 places where they intersect. 1, 2, and 3. Okay, so the answer here is going to be 3. Okay, write down the number of intersections. There's 3 intersections, therefore there's 3 roots. The number of intersections is the number of roots. When these are equal to each other, the x values of those points where they're equal, the x values are the roots. So there's going to be 3 roots here. Okay, because it stops at minus pi and pi. So there's not going to be any other place for any roots. although I know that this line is going to continue on and meet that curve somewhere later on down here, right? But we're only limited between minus pi and pi. Okay, so now what's next is for us to answer part 2 of this question. B part 2, it says the tan of x equals pi x in the interval from minus 2 pi to 2 pi. So we've got to basically think about extending this a bit between minus 2 pi and 2 pi. So let me make it a bit smaller first. All right, so these shapes are going to be basically replicated. So if I was to just extend this, make it a bit bigger. If I was to do the following and extend this, let me just both sides. Okay, so I've got it between minus 2 pi and 2 pi. So this is minus pi, and this here is pi. All right, so what happens, this continues like the same pattern here, it just continues over here. Okay, and that's going to be minus 3 pi over 2, where you have the asymptote. And then that same shape is going to repeat again, but this is going to be 2 pi. And you're going to have the asymptote at minus 3 pi over 2, so it'll look something like this. Okay, so that's going to be from minus 2 pi up to 0, and then the same thing happens here. This goes like that. You have another asymptote here, which is 3 pi over 2, and then you have the last section, which looks like this, between that and 2 pi. Okay, so we've got to think about how many times this line here is going to intersect those curves within the range between minus 2 pi and pi. So if we were to continue on this line, we can see that they're going to intersect again, there and there. Okay, so you can see there's 1, 2, 3, 4, 5. That's 1, 2, 3, 4, 5 points of intersection. Okay, between these two, between minus 2 pi and 2 pi. Okay, this one intersects again, nor will this, because that's going down, that's going up. So you can see there's 1, 2, 3, 4, 5. So we can write down the answer as simply just writing 5 here. So we can just put 5 intersections, and we can see that from the drawing, that's the answer. Okay, so again, here we have to just write down the answer. I'm just illustrating on these diagrams so we can understand what's happening. And then it says tan x equals pi x. So the same equation as this, but now the interval is between minus 100 pi and 100 pi. Okay, so we've got to think about this. Okay, between minus 2 pi and 2 pi, if you take away the one in the middle, you've got 2 pi solutions this side and 2 pi solutions. So you have 2 solutions that side, 2 solutions that side. So every 2 pi you have 2 solutions. Okay, so every 2 pi you have 2 solutions. And if you were to just take this whole thing and kind of like take this half of it and copy and paste it, you'll see every 2 pi, okay, will have every 2 pi will have 2 solutions. That means every 100 pi you're going to have 100 solutions. So you're going to have altogether 100 solutions in this direction. You're going to have 100 solutions in the positive direction. And then you're going to have this one in the middle. The one in the middle that we didn't count. Okay, it's like here you have 2 on this side, 2 on that side, and the one in the middle. Here, because, these, if you were to carry on, for example, drawing this one, they're going to meet eventually somewhere down there. Okay, and the same with, if I continue this one along, and this line, they would meet somewhere up here. And the same would go all the way up to minus 100 pi up to minus 2 pi up to 2 pi, and sorry, up from minus 100 pi up to 100 pi. So basically, you're going to have 100 solutions on one direction. So you have 100 to the right, to the left, and then plus 100 to the right. and then you have the one in the middle. So the answer is going to be 201 solutions. Okay, so that's just thinking about how this will repeat. This whole pattern repeats every. Okay, this whole section will just be repeated again. If I was to copy this and paste at the end of that, it would, it would be the same kind of look. And you'll see that this line, if you were to keep extending it, it would intersect those same places in those places. So you end up with 201 as your solution. 100 this way, 100 that way, and the one in the middle. I hope that's clear. And you understand how to do that question. That's question number 9, all about trig graphs and just basically trig graphs, knowing how to deal with them. There's other questions that you might want to see from this paper that you can find on the playlist. That the link will appear in this region at the end of the video. If you want to see other questions dealing with these trig graph problems, you can find them in the playlist over here. Thank you for watching. You can subscribe to my channel over there. See you soon.